You're listening to Skeptoid. I'm Brian Dunning from Skeptoid.com. Havana syndrome, microwaves, and hearing RF. Our world is filled with pseudoscientific ideas about radio being harmful. Whether it's the idea that 5G causes COVID-19, that smart utility meters cause cancer, or that Wi-Fi or cell phones cause just about anything, it's a constellation of related beliefs that science communicators are constantly having to combat. There must be a dozen Skeptoid episodes on the various manifestations of radio paranoia, and yet this particular failing of public science literacy is complicated by a few miscellaneous facts about radio that appear to poke holes in the science communicator's overall point, which is that radio frequency can't interact with or harm living tissue. Today, we're going to look at some of these and find out if the science fact that radio won't hurt you stands up to scrutiny. Whether you call it RF, radio frequency, or EMF, electric and magnetic field radiation, it permeates the entire universe. Every radio source in the cosmos sends out concentric radio waves that expand like ripples on a pond, but that quickly diminish with distance. These waves are what constitute electromagnetic radiation. Here on Earth, the overwhelming source of radio noise is the Sun, but other objects in the solar system, notably Jupiter, are making noise as well. Even distant quasars, pulsars, supernova remnants, and stellar nurseries are bathing us in radio signals every minute of every day. On top of all that, about 100 times every second, a lightning bolt generates a broad-spectrum radio burst that resonates worldwide through the atmospheric Schumann cavity. Never is the electromagnetic spectrum at rest. The waves emanating from a radio station's transmission tower, or from a cell phone's internal antenna, or from your Wi-Fi router, propagate just the same as those of natural origin. Just as large ocean swells move in some direction across the ocean, smaller waves of a different frequency can move right across them, with no interference. We can receive all those signals just by tuning our receivers to the desired frequency. We can listen to Iggy Pop, or we can listen to quasars. Both signals are around us all the time. So, for reasons that don't make much sense, those who vilify radio have decided that very specific subsets of those signals are harmful, while the vast majority of the radioscape is not. Science communicators point out that no radio is harmful. The noisy electromagnetic field is a fundamental of the fabric of the universe in which we all evolved. Below the visible spectrum, electromagnetic radiation has too little energy to strip electrons from atoms, so it can't do any damage to anything. It doesn't even matter how intense the signal is. No matter what you try and claim, radio cannot interact with your anatomy, so you cannot detect it, and it cannot hurt you. Wi-Fi, 5G, police radio, smart meters, I Love Lucy, or anything else. So now let's talk about some of the apparent exceptions that the radio hesitant often point to as evidence that this universal axiom is wrong. We'll cover 3. First, that microwave ovens can cook food and kill small animals. 2, that some people can hear electromagnetic radiation. And 3, Havana syndrome has been theorized to be caused by a microwave weapon. Okay, so let's start with microwave ovens can cook flesh. So this is indeed a real exception to the rule that radio can't hurt you. Radio that's incredibly powerful can heat some materials. Water molecules are magnetic dipoles. The oxygen atom at the vertex has a greater negative charge than do the 2 hydrogen atoms at the tips. So as any electromagnetic wave passes, it will subtly twist with the charge. But when that wave is ultra powerful, that twisting back and forth among all those water molecules with all the kinetic energy and collisions is what constitutes heat. This type of heating is in fact the one real exception to the rule that radio can't hurt you. So why don't we get burned from environmental EMF? like that from space or from radio stations, because the intensity is completely incomparable. A microwave oven takes a high-intensity microwave generator called a magnetron, harmonically amplifies its output through a waveguide, then bounces it around inside a reflective metal box. Some anti-cell phone activists have countered that their cell phone feels warm, therefore it's microwaving your body. No, your cell phone is warm from the heat from its battery and circuitry. Cell phones, or any other consumer devices, are not remotely capable of generating detectable microwave heating. So number 2, some people can hear RF. It is a fact that some people, when a powerful radio transmitter is placed next to their head, can hear faint sounds. These are reported as clicks, chirps, or a hiss. It's called the microwave auditory effect. What's going on here if radio cannot interact with ears? What's happening is the same type of heating we just discussed, only it's much too low to be perceptible, only about 5 millionths of a degree Celsius. Now, that's still enough to make microscopic expansions and contractions in the soft tissue of your head. It's called thermoelasticity, sending an acoustic wave via bone conduction to the inner ear. Even achieving just this 5 millionths of a degree is only possible when the powerful radio transmitter is placed right next to the subject's head. Electromagnetic radiation follows the inverse cube law. For each unit of distance away from the source you get, the intensity is reduced by the cube root. It's a very sharp drop-off, and it's why your microwave's magnetron has to be right there next to the metal box. Okay, finally, Havana syndrome and microwave weapons. There is a complete Skeptoid episode on the so-called Havana syndrome, episode number 603, Sonic Weapons in Cuba, which I recorded when vague sonic weapons were the media's favorite pseudoscientific explanation for the strange effects claimed by a number of staff at the American Embassy in Cuba in 2016. As made clear in that episode, there's little doubt that it was a mass psychogenic event, and a pretty good textbook example of one, too. Nevertheless, the media continues to be fond of trotting out exotic new explanations for it every time some pseudoscientific fringe claim is made. The latest is a microwave weapon, which hit the world news in December 2020, always with a headline suggesting that this was now proven to be the definitive cause. In fact, microwave effects are even a worse match for the inconsistent and disparate symptoms reported than was sonic weapons, but it sounded sciencey enough to be reported. There actually is such a thing as a microwave weapon. Sort of. A maser, or microwave laser, consists of a highly collimated beam of microwave energy very similar to a laser. They have a few applications, such as allowing the Voyager deep space probes to transmit data all the way back to Earth with an extremely low-powered transmitter. In a related concept, the active denial system is a non-lethal crowd control device that projects a 2-meter-wide beam of microwave energy at a target up to 1 kilometer away. It heats the target exactly like a microwave oven does, causing excruciating pain. To avoid injury, the microwaves are at an unusually high frequency, 95 gigahertz. As the higher frequency EMF is, the less it's able to penetrate. The active denial system is able to penetrate less than 0.5 millimeter into your skin. It's extremely effective as the pain is intense, but it's also easily defeated by lots of heavy clothing, simple aluminum foil, or even just hiding behind a trash can lid, but only so long as you don't leave any skin exposed at all. Compare this to a microwave oven, which, despite its high power, can still only penetrate about 2 centimeters into the food. This is much deeper than the active denial system because the oven uses a lower frequency, about 2.5 gigahertz instead of 95. It bears repeating that the intense pain from heat bears no similarity to any of the symptoms reported by the embassy workers in Havana. A government report published in 2020, an assessment of illness in U.S. government employees and their families at overseas embassies, cited the microwave auditory effect as being consistent with some of the symptoms. But this is a poor match. The only similarity is that some people reported hearing sounds, but completely unrelated types of sounds. Much of the rest of the paper's section on plausible mechanisms is highly speculative, and indeed its summary of an imaginary microwave weapon includes the blatantly false assertion that known RF effects include, quote, dizziness, headache, fatigue, nausea, anxiety, cognitive deficits, and memory loss. No. Radio is all around us, and there is no evidence that it causes any of those things. Unfortunately, the reporters who trumpeted microwave weapon as having been identified as the cause of Havana syndrome ignored that it was only one of 5 possible causes discussed in the paper, the last of which was psychological and social factors, the only one that checks all the boxes and the one broadly agreed upon as the true explanation. So once we look at only the real physical effect of radio frequency on humans, heat, ranging from undetectable in the millionths of a degree at unrealistically high power, to actually burning you at levels far above that, we find that there is no credible concern. But the anti-radio activists typically don't stop at the real effect. Instead, they search for imaginary effects. Chief among these is the claim that radio signals cause cancer, as widely reported in the worldwide press in 2016. The National Toxicology Program released the results of an unpublished study in which rats and mice were exposed to extreme levels of cell phone radiation for 9 hours a day over 2 years. Over 1,000 rodents were involved, but they were separated into so many different groups that positive results were always in the single digits. In other words, statistically insignificant. If significance was ignored, rodents were indeed slightly more likely to get tumors if they were exposed than if they weren't. And that is what the worldwide headlines screamed. It was meaningless noise in the data. The reporters never mentioned 3 other very important facts. First, that the study's only statistically significant result was that male rats exposed to cell phone radiation were more likely to live longer than those who were not. Second, that the study concluded there was no biological effect at all in females. And third, that the peer reviewers' comments savaging the study as uselessly horrible were also released at the same time, just apparently not read by any of the reporters. Even this most damning report against radio frequency finds that it makes male rats live longer and has no effect on females. To this day, the study has never been published. And so, in summary, we find that our apparent exceptions to the rule that radio doesn't hurt you all total up to a single exception, that radio signals have to be unspeakably intense before they can produce the one physical effect that they can. Simple heat. Not cancer, not autism, not any of the other effects that some attribute to radio. There isn't even a plausible theory suggesting the possibility of any other type of harm or interaction with the body. If you are one of those people who claims to suddenly feel a raft of physical symptoms when a Wi-Fi router is turned on in the next room, the laws of nature tell us it just ain't so. A great big Skeptoid shout-out to premium supporters Taylor Hempel, Alex Czar, Dan Pratt, and Swiss FileMaker developer Christoph Kaufmann. If you're a premium member, you can get your shout-out right here too. Just log into the members portal and go to Shoutouts and Stories and tell me what you want me to shout out. Simple as that. And all listeners are invited to jump into Skeptoid's Discord channel. Do you love Discord? Then you'll love chatting all about Skeptoid with your fellow listeners. It's easy to get in. Just come to skeptoid.com/discord. You're listening to Skeptoid, a listener-supported program. I'm Brian Dunning from Skeptoid.com.